Have you ever wondered what happens in the universe at the atomic level? Well, the answer to that question lies in the fascinating realm of quantum mechanics, a fundamental theory in physics that describes the behavior of nature at and below the scale of atoms. It's like peering into the secret life of particles, where the ordinary laws of physics take a back seat, and a whole new set of rules apply. Quantum mechanics is the bedrock of quantum physics, which further branches into quantum chemistry, quantum field theory, quantum technology, and quantum information science. Quantum chemistry delves into how particles combine and interact to form molecules. Quantum field theory explores the world of fields and particles, while quantum technology and quantum information science are pushing the frontiers of our technological capabilities. So, are you ready to delve into this intriguing realm where the micro and the macro meet? Let's embark on a journey to explore this fascinating world of quantum mechanics. In the quantum realm, things behave quite differently than they do in our everyday world. Let's dive into the heart of this realm, where the peculiar behavior of particles leaves even the most brilliant minds awestruck. Take the concept of superposition, for instance. In our daily lives, we're accustomed to things being in one place at a time. Your coffee mug, for example, can't be on your desk and in the kitchen at the same time, but in the quantum world, particles can be in multiple places simultaneously. Imagine being able to attend a meeting and take a nap at the same time. That's superposition for you. Now let's talk about entanglement, a phenomenon that Albert Einstein famously termed as spooky action at a distance. Picture this: you have a pair of dice, you roll them, and no matter how far apart they land, they always show the same number. That's quantum entanglement in a nutshell. Two or more particles become entwined in such a way that the state of one can instantaneously affect the state of the other, regardless of the distance between them. It's like having a magical thread connecting two objects, where a tug on one is instantly felt by the other. These phenomena, as strange as they may sound, are not mere abstractions or mathematical quirks. They are genuine aspects of our universe, confirmed by countless experiments. The quantum realm is a strange and fascinating place, a stark contrast to the world we perceive with our senses. It's a world that defies our intuition and challenges our understanding of reality. So, in the quantum world, particles can exist in multiple states at once and can be instantaneously connected to each other no matter how far apart they are. Now, how does quantum physics explain the building blocks of matter? Well, let's start with the atom. We've all probably seen the traditional model of an atom with electrons spinning around the nucleus in neat, predictable orbits, right? But quantum physics paints a different picture. Instead of definite orbits, electrons exist in cloud-like formations known as orbitals. Imagine a fuzzy cloud surrounding the nucleus where the electron could be at any given moment. The denser the cloud, the higher the probability of finding the electron in that area. This is known as the quantum model of the atom. But the weirdness doesn't stop there. In the quantum world, particles like electrons exhibit a strange behavior known as wave-particle duality. Now this sounds complicated, but stick with me. Normally we think of waves and particles as separate entities. Waves, like ripples on a pond, are disturbances that move through space. Particles, on the other hand, are tiny bits of matter. But in quantum physics, particles can also behave like waves. Imagine tossing a stone into a pond. The stone, a particle, creates ripples or waves that spread out across the water. Electrons behave in a similar way. When confined to an atom, they create standing waves, much like the strings on a guitar. The frequency or pitch of these waves corresponds to the energy level of the electron. This wave-particle duality is a fundamental aspect of quantum mechanics. It's what allows electrons to exist in multiple places at once, to pass through barriers they shouldn't be able to, and to display all the other weird and wonderful behaviors that make the quantum realm so fascinating. So, according to quantum physics, particles like electrons can behave both as particles and as waves. Quantum mechanics doesn't just explain the behavior of tiny particles, it also has profound implications for technology and information science. Let's dive into the intriguing world of quantum technology, where the principles of quantum mechanics are harnessed to create futuristic technologies that could potentially change the way we live and work. Two of the most promising areas in this field are quantum computing and quantum encryption. Quantum computing is an exciting development, and it's all about leveraging the quantum properties of particles to perform computational tasks. Traditional computers use bits to process information, which can either be 0 or 1. But in a quantum computer, we use quantum bits or qubits, which can be both 0 and 1 at the same time, thanks to a quantum phenomenon called superposition. This means a quantum computer can process a vast number of possibilities all at once, potentially solving complex problems in a fraction of the time it would take a classical computer. And then there's quantum encryption or quantum cryptography. It's a technique that uses the principles of quantum mechanics to secure data. The key to this is a principle known as quantum entanglement, where two particles become intertwined in such a way that the state of one instantly affects the other, regardless of the distance between them. This allows for the creation of encryption keys that are virtually impossible to crack. If a hacker tries to intercept the key, the very act of observing changes the system, alerting the rightful users to the intrusion. The potential of quantum technology is mind-boggling. We're talking about a future where computers could solve complex problems at lightning speed and where our data could be secured with unbreakable encryption. But remember, we're still at the early stages of this quantum journey. There are many challenges to overcome before these technologies become mainstream. So, quantum mechanics could be the key to creating super-fast computers and unbreakable encryption systems. We've covered a lot of ground in our journey through the quantum world. From the peculiar behavior of particles to the fundamentals of quantum physics, we've delved into the intricacies of the quantum realm and its impact on our everyday lives. Remember the double-slit experiment, that mind-bending demonstration of light behaving as both a particle and a wave? That's the quintessence of quantum weirdness right there. Particles like electrons and photons don't follow the rules of classical physics. Instead, they exist in a fuzzy state of superposition, being in all possible states at once until they're observed. Then they collapse into one state. It's like Schrödinger's infamous cat, simultaneously alive and dead until someone peeks into the box. We then ventured into the quantum model of the atom, a revolutionary concept that transformed our understanding of matter. We learned that electrons don't orbit the nucleus like planets around a sun. Instead, they inhabit clouds of probability called orbitals, where they're most likely to be found. This quantum leap from the classical model gave us the periodic table of elements as we know it today. This quantum odyssey wouldn't be complete without a look at the practical applications of these strange phenomena. Quantum technology and information science are harnessing the power of quantum mechanics to revolutionize our world. Quantum computers, for instance, use the principles of superposition and entanglement to perform computations at speeds unimaginable with classical computers. And it doesn't stop there. Quantum communication promises to create ultra-secure networks using the spooky action at a distance phenomenon, where entangled particles mirror each other's state instantaneously regardless of the distance between them. But this is just the tip of the quantum iceberg. There are still many mysteries to unravel, many quantum riddles to solve. Quantum gravity, for example, is an enigma that scientists are still grappling with. How does gravity work in the quantum world? How does it mesh with the other three fundamental forces? These are questions that may redefine our understanding of the universe. Quantum mechanics isn't just a niche subject for physicists. It's a fundamental theory that underpins our reality, from the atoms that make up our bodies to the stars that light up the night sky. It's a fascinating world that challenges our intuition, defies our everyday experiences, and pushes the boundaries of our understanding. So my friends, don't stop here. Keep digging, keep asking questions, keep exploring the quantum world. Read books, watch lectures, join discussions, engage with the quantum community. There's a whole quantum universe out there waiting for you to discover its secrets. Quantum mechanics might seem strange and counterintuitive, but it's this very strangeness that makes it such a fascinating and important field of study. Keep exploring, and who knows what quantum secrets you might uncover.